Hello again, everybody. This is Joseph. As I spoke before, I was speaking about power supplies, DC power supply. So I want to make a tutorial about this. And as you see right here, I have a DC power supply. Now, for a DC power supply, as you can see, there's a certain limit or spec that the power supply can give voltage and in current. As you see, 1 decibel is for voltage, the other one is for current. There's an A over there representing amps. There's a V representing the voltage. So you're measuring voltage and you're measuring amps. So now there's 3 terminals over here. One is ground, one is minus, one is positive. The output, the most output that this can go is 12 volts rated at 1.5 amps output. Whenever you look, it says output, how much the level of the power supply, how much it can give, the maximum level. Now, in that wiring diagram, usually there's chassis ground, there's earth ground. So usually I can, with respect to ground, I can use negative and I can use the positive terminals. In other situations, I could go and I could put the ground right to negative if I'm not using the ground. So, in this case, over here, as an example, just a demonstration over here, I set it up for approximately 7 volts. Now, as you see over here, just like any other power supply, 2 dials, 2 selectors. One is coarse, one is fine. Coarse means usually when you wind it up, you go to the level, but it's a little hard to get. Let's say you want 7.1 or something like that. It's a little hard to do with a coarse adjustment. Therefore, you need a fine adjustment. Fine is more, as you can see, 6.8, 6.9, 7, a tenth of a volt. Makes it more accurate for the decimal point that you need. So those two, continuous voltage adjusts as you see, will give you the voltage output that you need of the power supply. Now, you know that, let's say a circuit uses a specific amount of current, but that current or that circuit doesn't have a fuse or something like that, or a protection. This one has protection. As you see over here, the dial, continuous current. I can set the level of how much current I want the level of the power supply to give, and after that it will trip it. So in other words, this dial over here, when I do this button, I set it for approximately 0.55 amps, which is, like I said in the other one, move the decimal point 3 places to the right, and that will give you milliamps. So 550 milliamps. Anything more than 0.55, let's say I get 0.7, 0.8, will automatically trip it. And that's the protection of the power supply. Again, this is the adjustment. I can adjust it to anything. I can adjust it to more or less, depending on this one. And when it does go over, you see the LED light. So it has a protection. Again, here's black is for negative, red is for positive, always standard in DC. And then you go and you connect this one to this one. So that chassis ground will be earth ground. Now, it's telling me about 6.9, 7.0 volts. How do I know that's actually 7.0 volts? Well, when it comes to instruments, there's such a thing as calibration. There are certain companies who calibrate your equipment to make sure your equipment is calibrated correctly. Let me Elaborate. What does that mean? That means if I want to measure something, this power supply tells me right now I'm measuring around 7.0. How do I know it's actually 7.0 is correct on that power supply? Maybe it's 7.5. Maybe it's 7.6. Therefore, you calibrate meters, multimeters. You calibrate oscilloscopes for accurate measurement. That is almost a certification telling you this piece of equipment is accurate. Whatever it displays, it is accurate. If this tells me 7.0, that means it's giving an output of 7.0. Now, this is regulated. What do I mean by regulated? Regulated means when you put a load on something, it tends to make the voltage drop. Just like I explained in an alternator of a car, you have a regulator over there. When you put the accessories on, you put the lights on. When you use the body control module, the PCM, you put the radio, alarms, power doors, anything, any accessory that you use, the regulator of the AC of the alternator adjusts all the time to make sure that the output stays constant from 13.6 to 14 volts when you put a load on it. So when you put a load on this power supply, it should stay constant. It should not deviate and it should not go down. Because remember, when you put a load on something, like a resistor across here, you're pulling current. Well, since I'm pulling current to that component, this will tend to drop. The idea of regulation means even though I'm putting 7 volts to a resistor, I still want to have 7 volts being supplied to it and keeping it constant regardless of the loads that I put on it. That's called regulation. Another way that I can do this and figure out is by this way. I put a meter, the same meter that I used in the other one. And to elaborate, multimeters, digital multimeters. Like I said, you have to make sure to get a good multimeter. A good one means when you measure something, especially voltage, it goes in parallel across the component. The input impedance of a digital multimeter is about 10 mega ohms, which is high. Why do we need that? Because when you're putting a meter across something, you're putting it in parallel. Therefore, its resistance plays a role in determining how much the voltage measurement will be on the meter. The higher the resistance, the more accurate the measurement. That's why I say flukes that I've used in videos for automotive have 10 mega ohms, that's 10 million ohms. And it does not load down. The terminology is that it does not load down the circuit, meaning it will not give you an inaccurate measurement. If I have to measure 7 volts across something, it will measure approximately, let's say, within specs, 7.1, whatever, 7.1, 7.2. Whereas if I would have a meter with a very low resistance, like Harbor Freight, that is advertised all over in videos in automotive, I don't know why, that costs $5. There's a reason why it costs $5. Because it's only worth $1. So what you pay for is what you pay for. Therefore, get a meter with a high input impedance. Again, and these type of, when you look on the specs on the internet for multimeters, make sure you look for specs 10 mega ohm. Therefore, you will get accurate measurements. If you want to go to Home Depot or Harbor Freight, again, pay $10 or $15, like the videos tell you, you won't get accurate measurements. So, I want to stress one more thing. The decimal point. And I've seen a lot of good videos about multimeters. There's one point to be made also. This is 0.0. That means I can measure 9.9. But let's say I want to measure another decimal digit. Let's say I want to measure 9.99. Right? I want to be more accurate. Instead of 9.9, I want to measure 9.99. What do? Make sure, first, I use the highest range. If I'm not sure which voltage, how much the voltage is, we all know a car battery is 12 volts. But when the alternator is on, guess what? You're going to measure 14 volts because the alternator is recharging the battery, replenishing the battery. As I made so many videos in my other channel called Automotive Electronic Schematics by Joseph, which is obviously a promo. Anyway, I'm going to show you, I want to measure 7.0. I want to know if that's correct on this power supply. I set up my multimeter to see how much I measure for the output of this power supply. And I put it to 200. And there's a point to be made here in a second, and I'll show you. I'm going to make a multimeter, like I said, tutorial explaining kiloohms, mega ohms, because first you have to understand the units of measurement before you use something, as I spoke about before. So, in order to give an output, right now it's not giving an output. In order to give an output, I have to press this. We see where it says on or off? Pushing it in means it's on. When the button is out means there's no output. How do I know? You're going to look at the meter. I'm going to push the button in, and you're going to see an output. Look at this. No output. Right? Right there. 7.0. What do we measure here? 6.9, 7.0. Look at that. That's what a good meter is. I know that the power supply is accurate. I know my multimeter, which measures 7.0, is accurate because they're in sync together. How wonderful is that? So, that's what I mean by a good multimeter for automotive. High input impedance. When you look on the internet, look for input impedance. Not Harbor Freight that automotive mechanics talk about. So, remember I told you there's a point to be made. Right now I'm measuring 7.0. Let's say I want to measure a little more exact a figure, a decimal. 7.0 what? Well, guess what we do? And hopefully we're going to measure. Oops. Okay. Now, look at the decimal point. It gave me another decimal position. Now I can measure 7.00, whatever it is. Whereas over here, you cannot see it. See? 7.0. Let's look at the output now. Look at that. You get an extra digital place for more accuracy. So if I want to know how accurate this is, 7.0, I want 7 volts. Look at this. How close is it giving me within a speck? 7.00. That's why I moved the rotary switch down to get another position. You can start off with 200. You can start off with the other one. You can start off with 1,000 volts. But if you put in 1,000 volts, guess what? You're only going to see 1 decimal 7. If you put it in the next range under that, you're going to see 7.0. You put it on the other one, you're going to see 7.00. How's that for accuracy? Right? A great multimeter is a great multimeter. And that's why I've been preaching always to use good equipment. You're only as good as your equipment is. So, this is the type of equipment that I use when I have a diagnostics in automotive. I take an external power supply instead of using the battery. Why do I do that? Because the battery is set at 12 volts. An automotive battery is set at 12 volts. This will give me a variable where I can adjust it anywhere. As you see, 7, 8, 9 volts, 10 volts, 11 volts, 12 volts. For any voltage that I want up to 12 volts. Whereas the automotive battery cannot do that. It's set at 12 volts. The question is, you probably ask yourself, Joseph, why would you not want to put anything but 12 volts? Because don't the circuits in automotive work on 12 volts? Correct. That question is a good question. But the answer is, if you have a short or something, and modules or whatever, I do not want to put full voltage in that circuit because I'm going to blow it, obviously. If it blew a fuse, why would I put 12 volts on it? It's going to blow it again. So what do? I lower the voltage and I increase it gradually while putting another meter to measure the current at that location in the schematic. So let's say I have a fuse of 6 amps, up to 6 amps in automotive. Instead of starting at 12 volts, I'm going to start at 7 volts. I'm going to gradually bring it up. 7 volts, 7 volts, 8 volts, 9 volts. I'm going to look at the current meter. Remember, the fuse is, let's say, 6 amps. Right now, I'm at 5 amps. I increased it even more, 5.6. That's it. There's no reason for me, if at 8 volts, I'm almost measuring the maximum current allowed for that fuse, there's no reason for me to go further to 9 volts or 10 volts. I'm going to blow the fuse. That's why I use these type of equipment, to gradually maneuver or bring up the voltage. Just like in the olden days, we had it was called the Variac for TV. We didn't plug the TV into an outlet 120 volts AC if it blew the fuse. There was no reason to. We had an AC power supply. An AC power supply is, well, you bring it up 50 volts, 60 volts, 70 volts, and then you see how much current you're drawing. That is a method that you don't have to blow the fuses. So therefore, just like in automotive, just like I said, if there's a problem with the PCM, BCM, and there are hundreds of modules, I mean, it's amazing, diagnostics, I use a variable one because I don't want to blow the fuse. I'm going to bring it up gradually, 7 volts, 8 volts, and look at the current, how much I'm drawing. I'm going to look at the current. If I'm supposed to draw 6 amps or over 6 amps to blow that fuse, I'm going to look at this, 4 amps, 5 amps. I'm getting closer, no reason to go more than the voltage. I hope you understood that. And look at this. Look at this. 8.2, 8.26 volts. How accurate is that? That's an input impedance of 10 mega ohms. That's the difference between this Home Depot, Harbor Freight, and all these so-called multimeters that you see in other places. You want accuracy, somewhat. Okay? Anyway, please subscribe to my channel, Automotive Electronic Schematics by Joseph. As I said, I cannot put a custom URL, which I wanted to, because YouTube does not allow me yet. I haven't reached my subscribers that I'm supposed to. It's going a little slower. Well, anyway, and my other channel is Joe Electronic Schematics, which is transistor circuits, amplifiers, and I try to simplify and explain it in the simplest form for students in technical electronics and digital electronics. I hope you will visit my channels and subscribe to it. Like I always conclude, it's been an honor to instruct.